equals 3 over 2x plus 4. I subtracted 4x, and then I divided by -2, and then I plugged in 0 for y, and the x-intercept I got was 5 over 8, and then the y-intercept I got was -2.
Let's just push this a little bit. Yeah, get to see the answer there. Any questions on 14 or 16 getting the x or the y intercept? Is it? This guy right here for the x-intercept? Let's see. So if we plug in 0, yeah, I think she has it, yes, yeah. So just flip flop, I think 8 over 5 instead of 5 over 8. Questions? Nice job. Yep, that's it. So, Nick, you have the last pair of problems. They went together, that fundraiser problem. So if you flip it over and look at the word problems on the graph.
So I did 30 and 31. Okay, the swing changing colors. It's normal again. Okay, so I did 30 and 31. For 30, I got the equation as 4.5x plus 10y equals 2,500. And to get the x-intercept, I substituted in 0 for y, and then got 4.5x equals 2,500, and then you get 555.5 repeating, or 555 and 5/9. But since you can't sell 5/9 of a sandwich, the answer is 556. And for the y-intercept, I substituted in 0 for x. Got 10y equals 2,500. And then y was 250, so 250 pizzas. So for the 3 combinations, you could have 555 and 5/9, 0, or if you sold all sandwiches, 0, 250 if you sold all pizzas, and if you sold 20 sandwiches and 241 pizzas. Here's the graph for 30.
Does anyone have questions? Thanks, Brad. Any questions with 30 or 31, though, kind of pair of problems together? Nice job. I'll keep this. Just put your name on it. So for 28 and 29, that is another application problem. Please, nice job. Talking about the depreciation, again wanting you to find the x and the y-intercepts, but then also kind of talking about what they mean. So when you're looking at the depreciation equation, it has the 3v, and then it also uses a t. Which one of those would be your independent variable? So which would be your x variable, or represent the x variable? Which one would represent your y variable? Jack?
Would x be t and
Yeah, so the x value for the independent is your t variable. And why is that, Jack? Yeah, so time is always your independent variable. As time goes on, it changes depending on what we're talking about. In this case, we're talking about depreciation. So depreciation means something is losing value. So the value of the equipment is going to depreciate over time or go down over time as the time passes. So for that first question, you're asked to find the intercepts. So you would plug in a 0 for the v to find time. You would plug in a 0 for the t to find the value. And then it just asks you to explain what the t-intercept represents. So the t-intercept would represent the amount of time that has passed. So just looking at that little equation there, so we have 3v and then 250,000 times t, and then 1.5 million. But if you're finding the t-intercept versus the v-intercept, so you would plug in a 0 for the value if I'm finding time. Should have given myself more room. And then for the other one, I would want to solve for v, so that means that I am plugging a 0 in for time. So to find the amount of time, I would divide 1.5 million by 250,000. Or to find the value, I'd take the 1.5 million and divide it by 3. So that's how you would be finding those intercepts. And again, the t is really your x-intercept. That's your independent variable because things depend on time. So as time goes on, value changes. Questions? It then asks you to also find the slope, which means if you're finding the slope, you could have gotten that equation in, like solve it for v. That would have been one way to find the slope. So for 29, you would solve the equation for v. So you have to think when you have other variables in the problem, what do those variables represent? What represents the x variable, what represents the y variable, or the independent versus the dependent variable? Questions? So as I said, today we're going to write equations of lines. We're going to talk about two different forms. Slope-intercept form is the most commonly used form, but we're also going to talk about point-slope form and how it can be beneficial to use. And I'm going to try and get you to use point-slope form a little bit as well. Your homework tonight is in the book. So it's on page 101 through 103. I actually think it goes to 102. And then I think tomorrow's part of it goes to 103. But it's 1 to 29 odd in the book. So make sure you're looking at that on the assignment board, but it's also on the assignment sheet posted to Google Classroom and online or through Remind. So in your notes, if you can turn to section 2.4. So point-slope form is a way to write an equation of a line. and you literally are given a point and the slope, hence point slope form. So way to write an equation of a line, there are two different ways. Just like we can graph a line in two different ways. We can graph it with slope-intercept, we can graph it with the x and y intercepts. So we can write lines using a couple of different methods as well. So in the little box underneath, it kind of tells you the information you're given and a suggestion as to how to write the equation of a line. So the first part says if you're given the slope and the y-intercept, this is like the easy peasy, you have all the information, you don't need to do any work. So if I have the slope and the y-intercept, then you would just plug it into y equals mx plus b. Then it's no work whatsoever. You're plugging in the slope for m, you're plugging in the y-intercept for b. The second one is that point slope form. So if you're given the slope and a point, right here is the actual point slope form. So it says you're taking y, which is the variable in the equation, minus y1. That represents the y value from your ordered pair. It's equal to slope, which you're going to be given, and then x minus x1. So the x1 and the y1, that's the ordered pair that we would use to plug into the equation. And then the last possible option would be if you're given 2 points. So these are like 3 different cases of information that we would be given. If you're given 2 points, it says first use the slope formula to find the slope. So when I have 2 ordered pairs, we need to find the slope first. And then after we find the slope, we can use point slope form with either point in order to get the equation of a line. So we're going to see if we can kind of go through each one of those, and the notes are set up in that order just for you to see the difference between the 3 types of information that we can have. At the bottom of the page, it says write an equation of a line, and there are 3 parts here, so the graph is part of the question as well. If you're given the slope and the y-intercept. So this should be pretty straightforward. You're not doing any work for these problems. So we have the slope is 1/2, the y-intercept is 5. If I have the slope and the y-intercept, all we need to do is plug the information into y equals mx plus b. That's it. So Katrina, if we plug in the information for y equals mx plus b, your equation ends up becoming? Yeah. No work necessary, you're literally plugging in m and b. So Katrina, the second one, b, would be?
X plus -2.
Yeah, -2. Alright, so now we have a graph to look at, so you gotta do a little bit of work. Jack, when you have a graph, what do you need to do? Yeah, so we need to find where it intersects the y-axis because that's b. Your y-intercept would be where it's crossing the y-axis. This point is labeled, and that point is labeled as a 1. How would you find the slope, Jack?
I just found another point and figured out that it's
Yeah, so you need to find another point where your line crosses through a corner of a box. And then you're counting from one point that you have, which we know the point where it's crossing the y-axis. And then from that value, you're going down 3, so that means it's negative. And you're moving right 2, so that means it's positive. So the slope would be down 3 and right 2. So you rise or fall, and you run left or right. So Jack, that means the equation of the line for C is?
y equals -3/2 x plus 1.
So when you're looking at the graph, you need to get 2 ordered pairs, and you're kind of just counting from one point to the next. You don't actually need to calculate the slope because you've got a visual picture. Okay. So how far are you going up or down? How far are you moving left or right? Any questions on those 3? So the second case that we're going to look at is if you're given the slope and a point. And I'm going to try and get you to use point slope form to work through this problem. So it says write an equation of a line that has the point or passes through 2, 1. So that's my x1, y1. And has the slope of 2. That would be our m. So point slope form says take y minus y1, put it equal to the slope x minus x1. So Chris, what are we plugging in for the pieces of the problem here? What goes in?
The equation is y minus 1 and 2 x minus
So point slope form, you're taking the slope and the ordered pair and plugging them into the equation. And then you need to do a little bit of simplifying. So distribute the 2 and then get y by itself. So take the 2 through, and then your equation is 2x minus 3. So the great thing about point slope form is that your y variable is already in the equation, and you're simplifying it already in equation form. So see if you can solve the next one. Again, you're writing the equation of the line that passes through the point 8, negative 1, and has a slope of negative 1/2. Try and use point slope form. Make sure you simplify it. So you shouldn't have parentheses in your answer. Everything should be simplified out. So Josh, what does it look like when you plug in the pair, order pair, and the slope?
Y plus 1 equals -1
So when you're plugging that negative 1 in, and there's already a negative in the actual equation, that turns into a positive 1. And Josh, what was your final equation?
y equals -1 x plus 1.
Nice. So distribute the negative 1/2 through, take the positive 1 and subtract it to the other side. Questions? So point slope form. I'm going to try and get you to use that form instead of always reverting back to y equals mx plus b. At the top of the next page, there is the third option when you're given 2 sets of points and you're still asked to write an equation of a line that passes through these 2 points. So we have a point at -8 and 20, and then we have a point at -6 and 15. What do you have to do first to write the equation of a line, Peter? Yeah, we need the slope. So we have to know what the steepness of the line is in order to create the equation of the line. Peter, what is the equation of slope?
y2 minus y1
Yeah. So that'll be from Friday, the formula for slope. We have to find the slope of this line in order for us to then write the equation of the line. So Peter, what numbers go in for slope?
15 minus
Good. So that minus -8 turns into a +8. And then what do we get there, Peter? So that's the slope. What do you do next after you find slope? Josh? Yeah, so we're going to plug it into point slope form. Does it matter which point you pick? No. Choose the point that looks better to you. So maybe you like the point because the numbers are smaller, or you always just use the first ordered pair. But you can use either one of those points to write the equation of the line. So if you just want to pick the first ordered pair because it's listed first, then that's the point that you can use, but it's up to you. So y minus y1 equals the slope we just calculated, and then x minus x1. You could have used the other ordered pair as well. Michael, what is negative 5 halves times 8? Positive or negative? Negative. When you're multiplying, I know you all are grabbing those calculators, and remember, my goal is to get you not to immediately grab your calculator. You're taking negative 5 times 8. That's negative 40. This fraction bar is also a division bar. So negative 40 divided by 2 is negative 20. So Michael, what does your final equation end up becoming? Plus? Yeah, it is nothing. So you would add the 20 to the other side, which gives us a y-intercept of 0. So that equation is just y equals negative 5 halves x. So see if you can do the next one. Again, same type of problem, but you're given decimals. So if a problem starts with decimals, your answer should have decimals in it as well. If it starts with fractions, then your answer should kind of go through and become fractions or remain in fraction form as well. You don't have to convert those decimals into fractions. So however it's given to you, you should kind of use through the problem. Anybody calculate the slope? What'd you get? Negative 2.5 over. And then say again over 2 point. And if you actually divide them, what do you get?
That's a negative.
Yeah, I missed my negative sign. Thank you. Yeah, negative 1.25. So when we are writing the slope, we do want to continue to simplify it. So we don't want to keep it as a decimal divided by a decimal. Actually take those two numbers and simplify and get negative 1.25. So that would be the slope of our line. After you calculate that slope using point slope form, we have y minus 0.9 equals negative 0.125, the slope, and then x minus 0.6. So Josh, what would be negative 0.125 times negative 0.6? And your final equation of this line is?
Y equals negative 1.25x plus 1.65.
Does anyone have questions rating the equation of a line when you're given 2 points? So we started with just the slope and the y-intercept, so we just plugged them into y equals mx plus b. And then we had a slope and a point, so we plugged them into point slope form. And finally we have 2 points where you find the slope first, and then you plug them into point slope form. Questions? So the final option that's on there, besides a little application problem at the bottom, is what to do if you're trying to have parallel or perpendicular lines. So now I have 2 lines that we're trying to create to become parallel or perpendicular. It gives us information that you have a point, and then you have an equation. And that equation represents our first line. So our first line is y equals negative 2x plus 3. Our goal is to come up with a second line that would be parallel with the original line, and then another line that would be perpendicular with the original line. So just to have a visual, here is my current line. It's a decreasing line. Our goal is to come up with a line that is parallel to this, that goes through the point negative 1, 1. What does that mean that we're going to think about if I have a line that's parallel to it? Jack? It has the same slope. So we're going to try and come up with a line that's parallel, meaning it has exactly the same slope. So parallel lines have the same slope. So Jack, that means the slope of our new line has to also be, what's the slope of the line they give you?
Negative 2.
-2. So the slope of our new line has to be -2 because the current line slope is also -2. So my current line, the one that I have drawn over there, has a slope of -2. If I want to find a line that's parallel, it has to have the same exact slope. So its slope also has to be -2. The other information they give you is that it passes through the point -1, 1. So we're going to use that point and this slope to come up with our second line. And that's the line that I kind of have dashed in over there. So if I use point slope form, y minus my y1, the slope that's parallel means it's exactly the same, and then x minus x1. So the only part of the original equation that we're using is the slope, because we want to come up with a new equation that passes through that other point. And then I can kind of check my work with the little graph that I sketched. Ava, what would the equation of our line be?
I got y equals negative 2x minus 4.
So looking at my little sketch over here that I kind of dashed in, it looks like it's crossing through that y-axis at the -1, and it does have a slope of down 2 over 1. So now I have a parallel line. So I got the algebraic form over there, a little graphical picture to kind of go along with my algebra. How would you find a perpendicular line? So now we're going to take this same point, but I want a line that's going perpendicular. Something like this. Nick, what would that mean if we're trying to find a perpendicular line?
We would take the 1.77 form.
Right, so the slope has to be opposite reciprocals. And remember, that's from Friday when we talked about the slopes of parallel versus perpendicular lines. So Stephen, if our current slope is -2, what would the perpendicular slope be? Yeah. So opposite means it has to be positive, reciprocal means we have to flip it. So the parallel slope was the same. Again, we're using this -2 here, that guy right there, the -2, because that's the current slope. So we're taking the current slope, flipping it, and then also making it opposite. Plugging in the same exact way, so y minus, we're using that point of -1, 1. So we're using the same point, we're just trying to get a perpendicular line to go through that point. So y minus 1 equals positive 1/2, and then x plus 1.
I must be reading this wrong, but isn't x1 negative?
It is, but when you plug it into the equation that's already negative, it becomes positive. So Cole, what would your equation be then?
Y equals 1/2 x plus 3/2.
Nice job. Again, keep that as a fraction, not a mixed number. So you're adding 1 to 1/2 and you get 3/2. So now I have that line that's going perpendicular. So I have a set of parallel lines, and then we have that perpendicular. Questions? So there's one final little word problem down at the bottom, because you can always kind of do applications with slope. So we talked about writing the equation of a line based off of 3 different cases, and then writing the equation of a line if you have parallel versus perpendicular. So the last one is just an application. There it is. Says, in the school year ending in 1993, maybe we should change that to 2013. 2 million females participated in U.S. high school sports. By 2003, the number increased to 2.86 million. Write a linear equation that models the female sports participation. Use the equation to estimate how many females participated in 2008. So we'll use that last sentence in a little bit. Kind of stop there. The years really are kind of arbitrary. The number does not matter, that 1993. We could put any number in there, really. But 1993 is the initial year. We are not going to use 1993 in the problem because it's a year, it's not a numerical value. So instead of using 1993, we're going to represent it with a 0 because that's the original year. So 1993 in math, if I was doing math, that would really be the number 1,993. So when you have years in math, we end up using values to represent the year. So if I use a 0 to represent 1993, what would you use to represent 2003? Michael? 10. So this would be year 10. So in the year 0, I had 2 million participants. We're not going to write out that whole million value. We're just going to write it as 2 because we can put the word million in the answer. And then in the year 10, or 10 years later, we're up to 2.86 million participants. So we're kind of using this as like time that's passing, my initial data versus my data 10 years later. So see if you can write an equation to model the information that's given. So you need to calculate the slope first. And again, we're not using the years, we're using a number to represent that years to show us time is passing. And then try to use that point slope form to come up with the equation of your line. So your equation, your slope is 0.086x, and then plus 2. Nick, question?
Did you just use slope intercept form?
You could use slope intercept form as well because yes, you're given the y-intercept, so that would give you the same value. How would you answer the final part of the question? It says, use the equation to estimate how many females participated in sports in 2008. Nick, how would you use that 2008?
Substitute 15 for x.
So 2008 is 15 years after 1993. So you take your equation, and as he said, you're plugging in the 15 for x. So you're not plugging in 2008, but instead you're plugging in the number that represents that year. So how many years have passed since the initial year that we've talked about? So again, your homework is in the book tonight. It would be the odds, 1 to 29 odd on page 101. That number should be 3.29 million females. Don't forget that word million, because that number does represent millions of females. Is there a volunteer interested in doing 17 or 23? Peter 17, Nina 23. Have a fantastic day.
Two.
Thanks.